Welcome, everybody. Thanks for your patience. Today, we have a variety of testing tools for Android, automated testing tools, including JUnit, Mockito, Robolectric, Espresso, UI Automator, and more. But how can we design our applications to leverage each tool most effectively and at the same time ensure that our code is readable, flexible, and maintainable? My name is Chuck Greb, and I lead the mobile engineering team at Mapzen, where we build collaborative tools that harness the power of open source as well as open data to build mapping and location-based apps. Now, I've been giving talks for a number of years about testing on Android since the early days when we didn't have such a wide variety of tools available. And normally, this would be the point when I would get up on my soapbox and try to convince everybody here about the benefits and why you should be testing your code. But I don't really feel like I need to do that as much anymore, as over time, testing has become more part of the mainstream culture of Android development. And that's a good thing. So this talk isn't going to focus on the why you should be testing as much as it's going to focus on the how. As the Android platform has evolved and matured over time, so have the tools that we have available for testing, and so has what we as developers consider to be best practices. And so when we're talking about testing, what we're really talking about is quality. As developers, we want to have confidence that the code that we're delivering behaves in the way we expect it to behave. Another topic that's become more part of mainstream Android development culture over the last few years is that of clean architecture. Now, these are not new concepts in software development. Testing, clean architecture, these things have been around a long time, longer than Android itself. But what is new is us as a community figuring out the best way to apply these classic principles to the Android development process, given the unique nature of the platform. And so let's take a quick walk down memory lane here, and we're going to do so from the perspective of looking at how the way we build apps on Android has evolved over time. So how many people here, with a show of hands, are Android developers? Okay, most of you, as I would expect. Well, hold on, keep your hands up. Now, how many of you who are Android developers have been developing, let's say, since Marshmallow was the current version? Okay, most of us. What about since, let's say, KitKat? Good. How about ice cream sandwich? Okay, still a good number. How about, let's talk about pre-honeycomb. How many people have been developing since gingerbread? Okay. And going back to, say, Froyo, Eclair. Actually, I have to put my hand down now. What about alpha and beta? Okay, now you guys are just showing off. I did get started with Android development right around when version 2 came out, Eclair. And although some of the early apps that I worked on, we did test all the way back to Cupcake. And so I did a fair amount of testing on the G1. However, my first device was the original Motorola Droid, complete with slide-out keyboard, directional pad in all its awesomeness. And I was very happy to see this device get a shout-out yesterday at the keynote with Roman and Chet, because it still is near and dear to my heart. Now, regardless of when you started doing Android development, whether it was with a more recent version or whether it was going way, way back into the early days, chances are we all started the same way, with an activity. And so this is the basic construct that almost every developer has used throughout the history of the platform when they begin building an application. And well, what does an activity do exactly? A few different things. It's your hook into the underlying system in that your activity has a life cycle. And this is how the Android framework interacts with your application, with your activity when it starts up. There's different lifecycle methods that get called that we're all familiar with, like onCreate, onStart, onPause, onStop, onDestroy, and so on and so forth. And so this is how the system gives directions to your app. The activity is also a context. So what does that mean? It's your gateway to the system services, things like the layout inflator, or the location manager, the package manager, or even shared preferences. So the activity already has quite a few responsibilities. Well, and then most applications that we're going to build are going to have some sort of a UI associated with them. So let's say, for example, we want to add some UI components to our activity for this demo app, including a text field and a button. And well, oftentimes, applications are going to want to also fetch some sort of data from a web service remotely. And as good developers, we don't want to block our UI thread. So we were given this task, or this component inside the framework called async task, which allows us to push some work to the background thread, which we can use to connect to a web service. And then maybe we want to take that data and persist it in some way locally, in some sort of local storage, either in a flat file or shared prefs or SQLite, or take your pick. And then along came fragments. And fragments were introduced along with originally Honeycomb, and then for tablets, and then eventually Ice Cream Sandwich for the rest of the devices. And what fragments really gave us was some sort of a sub-activity component that was meant to be more reusable, and also giving us the possibility of adapting it to different form factors, right? Well, so there were definitely some upsides that came along with fragments, but there were also some downsides in that the fragment has its own life cycle. So now we have not only the activity life cycle to worry about, but also a fragment life cycle. So we did get some benefits, but we also did incur a lot of increased complexity with this sort of approach to Android development. And then we can't forget that this whole time, users actually interacting with our application. It doesn't just exist in a vacuum. And so they're going to be clicking on buttons and entering text into our text field. And we might want to perform some kind of input validation to verify that the input that we're receiving from this human who's interacting with our interface actually makes some sort of sense in our program, and hopefully prompt them along the right path. And then take all of this that's going on, and then if the user actually is bold enough to go ahead and rotate the device, it's all going to get completely destroyed, torn down, and recreated from the ground up. And so we need some way to be able to hold on to the state of what's happening right now, especially if we have some long-running process in the background. So one way that's available for us to do that, or that has been around for a while now, is to retain an instance of our fragment, especially one that's fetching data from a remote service. And then we can restore that post-configuration change. And then all of this that we've described up to this point really just describes one screen, one piece, one part of a flow in our application. And if you wanted to move to other parts of your app or different flows, then what we would do is typically fire off an intent to start some new activity, parcelable, add some parcelable extras into the bundle, and send that off and move the user along to the next piece in the flow. And then at some point we said, hey, let's write a test for all this. Well, given the architecture that we just described, I would argue that it's going to be very difficult to isolate any one of these components and write a unit test for it to verify that it's behaving the way we expect it to behave. I mean, one of the primary purposes of tests are to discover bugs in our application. How many people here write bugs in their code? Oh, okay, I thought I was the only one. All right, so given that we expect to discover some number of bugs in our code, that will probably lead us to want to make changes to our app to correct that behavior. Well, not only is it going to be difficult to test any one of these components, given the architecture that we just described, but it's also going to be difficult to change them. Because when everything is tightly coupled and bundled like this, if you want to change one component, chances are you're going to have to change all the code around it as well. And so really what we have here results in a tasty burrito sort of a pattern architecture for Android development. It's as if you get to the end of the line in Chipotle. Do they have Chipotle in France? Yeah? Okay, good. So you get to the end of the line at Chipotle, and after you picked all of your different fillers inside your burrito, you say, you know what? I changed my mind. I don't want white rice anymore. I think I actually want brown rice. Well, they can't just swap one in for the other. Basically, the employee would have to rebuild you a burrito from scratch. And that's what we would, or at least it would feel like we would wind up doing anytime we would want to make changes to our application, given the tasty burrito pattern. Now, it's not to say there weren't any testing tools available throughout the history of Android development. Actually, there was a testing framework that shipped with the original versions of Android that included components like this one, Activity Instrumentation Test Case 2. And this was part of a whole suite of instrumentation tools that was kind of the precursor to Espresso, but lacked a lot of the niceties, like being able to wait until the view has loaded or till some asynchronous operation has completed. And so it made testing really difficult. It also required that you launch your application on either an emulator or device, even to run the most basic of unit tests, which really slows down the process, and especially if you're trying to do anything like test-driven development. And then, God forbid, you actually attempted to run a test on, locally in the JVM for any class that actually depended on a piece of the Android framework. You would quickly run into an exception that looked like this one, up until recently when we got the actual mockable versions of the Android jar that we now can build against in our local environment. Well, fortunately, things are better now, and over time, many different tools have been introduced, and the Android framework itself has been, or at least the way that you build it locally, has been adapted to where we can take advantage of other tools that have been around that can help us so that we don't have to take such a black box approach to testing. That still doesn't solve the issue of our architecture. Even given all the tools we have today, building apps the way we described in that first example is still going to make it really challenging for us to isolate a component and test that it behaves correctly when given the right set of inputs. So what can we do? Well, for starters, let's take that original activity, and given that the activity already has so many responsibilities, responding to lifecycle events, interacting with system services, what if we offload some of the responsibility of that activity and take the logic that determines what to show to the user and when to show it and move that out into a separate class? Well, if we're going to separate our logic out of our activity, then why don't we go ahead and take it another step and separate our data as well? Seems reasonable, right? And now, also in the Android world, we have this concept of views, and one way to approach it is to say that, you know, an activity contains a number of views, but if you're like me and you enjoy using compound views and extending the framework view classes to customize the behavior or group a number of them together, then you wind up having these views that are a little bit more complex than just dropping in an XML line in your layout. And so you're going to want to start to think about your views as their own separate classes as well. But then the question becomes, what do we call these things? Now that we have some degree of separation of concerns, how do we refer to them when we're speaking about our application? There's actually a great riff on this quote that I really like. Somebody took the original one and tacked on not just that there are only 2 hard problems in computer science, cache invalidation and naming things, but also errors off by 1. So given the clean architectures that we looked at in the beginning, let's see how those might apply to this scenario that we just came up with. So if we look at MVC, Model View Controller, we can say, all right, well, we can call our logic our controller, and we can call our data our model, but then we wind up calling our activity our view, but then we have these other things that are also called views. So it starts to become an overloaded term. That's a little bit confusing, right? Same thing with Model View Presenter. Now, notice the arrows in these are slightly different in that it implies a different way, a different flow of information. But again, we inherently have a 3-entity system that we're trying to apply to this 4-entity Android architecture that we've teased apart our activity into. Same thing with Model View View Model. Now, I'm not trying to suggest that all 3 of these patterns are exactly the same, because they're definitely not. But again, they're all trying to apply 3 different labels to a 4-piece system. And so I said, well, why are we only allowed to have a presenter or a controller? Why not use both? And so in this example, we can see that we're calling our presenter our logic, and we're calling our activity our controller. And this way, our views can just be views. We don't have to worry about whether our view is an activity or whether our view is a controller. I agree. An argument I hear a lot is this is just semantics, what you call these things, and it's OK if you call the activity the view. But I think it's important because the mental constructs that we use when we're building software, the actual way that we implement it tends to mirror the way that we think about it and the way that we describe it. And so for me, it's helpful to call a view and an activity something else, like a controller. And so let's take that one step further and say, well, our activity isn't our concrete controller, but rather it implements this controller interface. And that's going to be key when we look at the relationship between how the presenter and the activity communicate with each other. There's some more seats up front here if anybody wants to move up. And now we can see as we start to add back in all those other pieces that we looked at with the initial example, they kind of fall into place with a nice separation of concerns to where we don't have everything bundled up in our activity anymore. Really, our activity is primarily concerned with those two initial things that we spoke about, the lifecycle and the system services, and all the responsibilities of our UI are now getting pushed into the view. Our presenter is handling our logic of figuring out what to display when, and our model is taking care of accessing our data and persisting it. Now, what this allows us to do is draw a line right down the middle of our architecture and say, this half cares about Android, this half does not. Last week when I was prepping for this talk, I sent out a poll on Twitter to get some feedback from the community about what tools folks like to use most for unit testing. I'm not going to share the results just yet, but I will tell you what the options were. I couldn't find a way to get a nice picture of this without revealing the responses. So the question is, which framework do you use the most for unit testing on Android? And the options given were JUnit and Mockito, B, Robolectric, C, Espresso, or D, I don't unit test. Before I share the answers with you, let's talk a little bit more about exactly what we mean by a unit test. So some of you might be familiar with the test pyramid. This is a concept that was introduced by Mike Cohn in his book, Succeeding with Agile. And it basically describes the different types or the different layers of testing you can have in a software application, and also kind of what their relationship is to each other, in that as we move up the pyramid, our tests tend to get more expensive and slower, and as we go down the pyramid, our tests tend to run faster and are less expensive. And so anyone who adheres to this sort of principle when they're thinking about their testing strategy wants to make sure that they have the greatest number of unit tests and then a smaller number of service or integration tests, and then even fewer than that, UI or end-to-end tests. And there's some definitions there on the side that kind of describe what each of these do. One other interesting note that I always like to share along with the test pyramid is that if you have a failure in a higher level, either a UI test or an integration test, then that often is indicative of a missing unit test as well, implying that we should have better coverage with our unit test than we do with our other layers of the test pyramid. And then I'd also like to share this set of unit test rules that comes to us courtesy of Michael Feathers, which really gets at some hard and specific conditions about what a unit test is, and more specifically, what a unit test isn't. So a unit test is not a unit test if it talks to a database, if it communicates over a network, if it touches the file system, if it can't run at the same time as other tests, which gets at things like concurrency and also shared resources. And finally, if you have to do special things to your environment, such as editing a config file. And so coming back to our poll, now that we have a better idea of what unit testing actually is, let's take a look at the responses. Well, I'm happy to say that 60% of those who responded got it right, and they chose the only one that is actually unit testing. We did have some number of responses for both Robolectric and Espresso, which I would argue aren't unit testing frameworks. Maybe Robolectric started out as one, but I'll talk a little bit about why I think that's transitioned to be more of an integration testing framework. And then Espresso, being more UI-driven, definitely is not, does not adhere to our definition of what is a unit test. And then I was also sad to see that there's still 19% of us who aren't testing, but hopefully this presentation will help change your mind. And giving credit where credit is due, at least one person figured out that this was a trick question. So now, taking Mike Cohn's original test pyramid, let's look at how that might apply to Android development. And so, given the different tools that we've spoken about so far, this is how I would break them down into the different tiers of the test pyramid, starting at the bottom with your solid foundation of unit tests driven by JUnit and Mockito running in the local JVM. We're using a completely mocked version of the Android framework here, the version of the Android jar that ships with the SDK that does not have any real implementations. And any behavior that you want to customize out of it, you have to prescribe using mock objects. Moving one level up the testing pyramid, the idea of a service level or an integration level test is kind of this middle ground between running your full stack in a real environment and mocking everything. And that's where I believe Robolectric is at today. So when Robolectric first came out, it behaved very much like a unit testing framework in that it mocked the entire SDK or shadowed it using this bytecode manipulation to get you to some sort of alternate implementation of the framework classes. Well, now it runs against the actual Android jars, mocking only those components that hit some low-level or native system component, or those that deal with the actual physical display. And so now you're running against the real version of the Android framework, still in the local JVM, however, you get more realistic behavior, but it also comes at a cost. We're moving up the pyramid, loading the real Android jars, spinning up the real system components, takes time, and so our tests get a little bit slower and a little bit more brittle and ultimately more expensive. And then finally, the UI tests using Espresso to drive your application through the UI on an actual emulator or device is at the top of our pyramid. And so I would argue that all three of these are essential components to any comprehensive testing strategy for Android. And just to really drive this point home, this diagram comes from the actual developer documentation for the testing support library to really kind of illustrate the difference between a test running locally on your laptop in the JVM and one that's running on an emulator or a device. So now, given that we have a better understanding of what the different levels of the test pyramid are, let's take a look at each one a little bit closer. So using our decoupled Mvpc architecture, unit testing becomes rather simple if we concentrate on the half of our app that doesn't care about the Android framework. And so we take our presenter and our models in isolation, separate them from our activity, separate them from our views, and we replace our activity with a test implementation of the controller, which allows us to verify the way that the presenter is interacting it without running the actual activity code. We're using the JUnit test runner to run our tests on our local environment, and then we also don't want to be making any calls to the network or to some sort of persistent storage, and so we mock out that behavior as well. And then one key point here is that previously we replaced async task with thread. Normally, if you're going to start a thread, then you would call the thread start method. In our tests, we'd rather call the run method, which will execute the same code that would run if we executed thread.start, but it would do so synchronously. And so we can test the actual code inside of our network requests and our storage persistence layer without actually executing it asynchronously. And so let's just walk through a quick example here for this login presenter. So imagine we have an activity or a view in our application that presents the user with a username field and a password field and then a button to authenticate with the app. And so that activity is going to be interacting with our presenter primarily through one method here, which is on login button click, which sends in the username and the password. And then we're going to do what we need to do against the account validator model to verify those credentials, and then call the appropriate callback depending on whether it's a success or a failure. Now remember, when we're unit testing, we don't care about the actual concrete implementation of our activity, and so what we're more concerned with is the controller interface that it implements. And so what we have is a test implementation of that controller that essentially just gives us an ability to sense which one of these methods were called when. We also want to use a test version of our model, which is our account validator in this instance, to prevent it from doing the actual network access or database access. And so we're going to have some hard-coded credentials that we know will succeed in our unit test environment. Then the actual test itself. And so what we're testing here is we want to verify that when on login button click is called with the correct set of credentials, that then the presenter notifies the controller that this request succeeded. Similarly, if we call it with an invalid set of credentials, we want to make sure that the error state is invoked on our controller. And you can see now that we've put all these kind of building blocks in place, these mock objects, this test harness that we have, the scaffolding, the tests themselves become very easy to write. We have a test implementation of our controller, we have our real presenter with our test model, and then we just simply call the methods directly on it and make sure that it does the right thing. So next, let's take a look at how we might approach writing an integration test. Well, so like I said, I think Robolectric is kind of in this sweet spot now, which gives you this middle ground between unit tests where you need to mock everything and UI tests where you need to actually deploy your application to an emulator or a device to figure out what's going on with it. And it does so through providing us with some sort of a simulated runtime environment that we can still run in the local JVM, but it's actually based on the real Android framework classes. And so really at this point, we're only mocking out two things. We're not using as many mocks as we were with the unit testing examples, but we're mocking out the two extremes here of what is actually UI code that's associated with our physical display because we're running headless. There's no actually display associated with this. And then we're mocking out at the other extreme any live calls over the network or to persistent storage. Maybe we're doing so with like a local mock server or something like that, but I would still want to avoid going out over the real network for an integration level test. And so this allows us to get slightly more realistic behavior out of our test environment without incurring all the downsides of deploying to an emulator or device. And so when we run these tests, you can see we're using a lot less mocking code because we have the things that need to be mocked are already mocked for us by the Robolectric framework. And we're able to do things like interact with actual view components, like the text views and the button. And then here we have a test listener that we're using just to, so I should describe the way this login form works that this test is written for is it's a compound view that extends a linear layout that contains the username and the password field and the button, and then the activity simply sets a listener on that entire view. The login form itself knows how to validate the input to make sure the email address looks like an email address, the password field isn't blank, things like that. And so we don't want to invoke the on-click listener up to our activity until we actually make sure we have some sort of valid input. And so that's what this is testing. And then finally, let's take a closer look at how we might approach writing a UI test with Espresso. So now we see that given the architecture we previously described, we're using the least amount of mocks in that we're actually launching our full-on application on an emulator or a device, and we're giving it real input through the UI. So this is a literal end-to-end test, hitting the live network, hitting live storage, that verifies that our complete stack works together the way we expect it to. Now you can see why we wouldn't want to base our entire testing strategy on something like this, because it requires a live network and the storage working correctly and might behave slightly different on different devices. But given that final line of defense after our unit tests and our integration tests, some number of UI end-to-end tests can be extremely valuable. And so the Espresso framework, here's an example of a test written using Espresso. Gives us some nice elements to use, like view matchers, view actions, and view assertions. So what we're doing here exactly is, well, that first test is just kind of the one that it gives you when you spin up a new app. And sometimes I like to keep it in there just to verify the environment's configured correctly. All it's doing is verifying the package name. But then the second test is the real test here, which is wants to make sure that when that on-click event happens for our login form, that we should hide the, or rather, instead of showing the email and the password fields and the button to log in, we want to show some sort of progress indicator. And so we actually wait for the view to load on the emulator or the device, and then we use a view action to perform a click on that. And then we can also wait until the progress view becomes available, referencing it by its ID, and then match that it is displayed to the user. So there are a number of questions that I frequently get when talking about these topics, and so I'd like to address a few of those now in anticipation of some that might come up later. So I would say the three most popular categories of questions that I receive about this is around configuration changes. Also, another popular question is whether or not views can have their own presenters. And finally, what should I do when I'm dealing with some sort of untested code base, aka legacy code? So dealing with configuration changes with this approach, I think becomes much easier than when you're dealing with the tasty burrito, in that when the device is rotated, our activity in our view is going to get destroyed and rebuilt, but not necessarily our presenter and our model. So now one way to handle configuration changes would be to have your presenter actually persist through the change and then restore the state of the activity. This can get a little bit dicey at times, because if you have a lot of presenters in memory, or also dealing with figuring out whether or not this was it's time to actually kill off the presenter because maybe we're moving on to a new flow in the app. So you have to put some extra controls in there to manage the lifecycle of the presenter. Alternatively, we can allow our presenter to be scoped to the lifecycle of the activity, but then we would still need some other way to persist the state of the app through the configuration change. In which case, I would suggest introducing a special model that is specifically tasked to that purpose. You could call it something like the view state manager that would remember what action the user was performing and what was the state of your UI at the time the configuration change occurred, and then you can restore it based on that with a new instance of the presenter activity in view. So another question I'll hear a lot is, well, okay, so you're calling your activity a controller, and that's got a presenter, but can your view also have a presenter? And the answer is absolutely yes. So you can imagine a scenario where your view starts to incur more logic and will need to interact with, you don't necessarily want to you want to be able to make that logic testable, unit testable, and so it's to your advantage to extract that out into its own presenter and model hierarchy. And so this leaves you with more of a classic MVP pattern, where the view can offload its inputs to its presenter and then finally perform its validation against some model that describes what is valid input. And then getting to the idea of legacy code. And what exactly is legacy code? Well, one definition of it that I tend to prefer is simply code without tests. If you have a code base that's untested, that implies that it can be difficult to change, it can be difficult to know when things are broken, and it can also make working on it just generally challenging, especially when it comes to if you want to start adding some amount of testing to that code base. And so my advice for dealing with an existing code base that you want to start introducing some idea of clean architecture or testing to would be that first you need to realize that code that doesn't have test was probably not written to be testable. And so going back to the beginning of the presentation, if you have your tasty burrito and then you all of a sudden want to add a test for it, it's going to be really hard to tease apart those components and test them in isolation. And so I would caution you, please do not, I've seen this happen too many times, say, okay, we're going to take the next 2 weeks or the next 6 weeks and we're just going to write tests. We're going to get code coverage on this code base. This is not the right way to approach testing an untested code base. More often than not, what this leads to is just kind of spinning your wheels and refactoring things that may not need to be refactored and maybe breaking things that are currently working, and tends to be more of a headache than it's worth. And so what should you do instead? Well, I would say start with testing any new code that's added. Along with that, also think about testing the code around the new code that's added, in that anything that it interacts with will also be impacted by these changes. This way, you're going to automatically wind up getting the most test coverage around the parts of your application that change the most frequently, which arguably is the part that needs it the most. And then finally, I would say get this book, because it gives you a lot of good strategies for kind of breaking existing dependencies and creating seams in your application, where you can start to decouple and isolate components to make them more testable, where they otherwise might not have been. Now, a lot of the ideas that we talked about today are available in a sample app that I have on my GitHub page, ecgreb/mvpc. So check it out and let me know what you think. I'd be very interested in any feedback. So, all right, so let's summarize what we talked about. So, number one is using some sort of clean architecture in your application can help your code be more reliable, more maintainable, and more testable. You should choose an architecture appropriate to your use case. I'm not going to say that Mvpc is a silver bullet and every Android app out there should be using it. What I am going to say is that we have a variety of tools in our toolbox here now, and we're just sort of figuring out now how to use them on Android, so use the one that fits your use case the best. I would advise that you should write unit, integration, and UI tests that work in conjunction with your architecture rather than working against it. And then finally, I would say, please don't be overly dogmatic about your approach to architecture and testing, especially if you're trying to convince other individuals, maybe coworkers, developers, stakeholders on your project, about the benefits of testing, because this can be a real turnoff. The concepts that we talked about today are not black and white, but rather there are many different shades of gray. And remember that software development is as much an art as it is a science. Thank you. Okay, so we have 2 minutes left for some questions. In the back.
Thank you. In your example, you didn't use any dependency injection tool or framework. What do you think about that?
Yeah, so in these, sorry, the question was about dependency injection frameworks and that I hadn't used them in any of these examples. I think they're fantastic. And specifically with the, we saw the one example of writing unit tests with the login presenter and passing in the account validator, excuse me, as a model. into the presenter. So this is an example of dependency injection. This is constructor injection. This is one way to do it. It's not using any particular framework, but it's instead of creating a new account validator inside our presenter, we're handing one in through a constructor parameter. There are frameworks that also provide dependency injection, like Dagger, for example, which I think are excellent. I left them out of these examples just because I wanted to kind of make it as simple as possible, but I would encourage you to definitely check them out. Especially the most recent version of Dagger, Dagger 2.10, has these nice components have been added for specifically Android injection, which makes it even better than it was before.
This is a really semantic question, but in your new MVCP, I guess, you have the activity like extended the controller, and then you have a presenter. And I was just wondering if it wouldn't make more sense to call the activity the presenter and what you have presenter called the controller. I mean, I understand that in the case when you have MVP, then the presenter is actually doing this work. But in the case, in our case here, the activity will be just in charge of telling the view what to do, and the controller would be the one doing the work. It probably would make more sense to me to call it controller for the logic and presenter for telling the view what to do. What do you think about that?
I think it's a great suggestion, yeah. So the idea of calling the activity the presenter and rather the presenter the controller. Sure, I think I chose to approach it as calling the activity the controller mainly because of the way that it interacts with the lifecycle, and also tends to listen for some of the events that happen on the views. And so from that perspective, it seemed to fit the definition of a controller. But like I said, naming things is hard. And perhaps going the other way has some advantages as well. Yeah, thanks for the suggestion. Maybe we have time for one more? Well, perhaps that's it. Thanks again for coming out. Enjoy the rest of the day.